Alright guys, welcome back to ACIB. Today I'm going to be talking about measures of dispersion. So first of all, I want to talk about a few different ways we actually categorize the range of data. So we know about the median. So let's just take a look at what we covered last video. So the median is, remember, the middle value, so the value in the middle value, or it is the average or of the two middle values if the data set has a even number. Apart from the median, we also have the interquartile ranges. Commonly denoted as the IQR. So this basically, just like the median, divides the data into four sections, so quarters. So we have the first quarter, or basically we write it as Q1 and Q3. So and the way you want to find this is pretty similar to the median. So let's say we have a data set here, right? So first of all, what you would do is you would find the median. So obviously the middle value to you are the two fives. The median here would just be 5. And then what we do is we split the data set into two. So now we would be looking at the first half of the data set, and then we would take a median from here. So once again, the median here would be 3. So Q1 would be 3 in this case. Same thing here. We take the median from this side, 6 and 9, that would be 7.5. So Q3 equals 7.5. Note that if there is an odd number of elements, so let's say there was maybe another 5 in here, and then this would be counted as a median, then this 5 would not be counted when you do the median calculation for either quarter. So you would still do a median calculation for this for Q1, a median calculation of these four for Q3. So if you have odd numbers, then the median is not included. Alright, so now let's get into the meat of today's video, measures of dispersion. So we want to measure dispersion, or basically how spread out the data is. So for this job, we usually have a standard deviation, which is the square root of the variance. The IQR could also be used. For example, you can calculate the IQRs, so that would be Q1 and Q3, and then compare them to the median, and then also compare them to the range, and then you can see how different the Q1 and Q3 is to the range, and you can deduce how spread out the data is. But for a more concrete way, we use something called the standard deviation. When you first hear this term, it might sound a bit scary, but trust me, it's not, and most of the time you don't even have to calculate this yourself. This is usually represented using this sigma, and particularly standard deviation is the square root of variance, which is denoted as sigma squared. Particularly, variance is defined as the sum from I equals 1 to n of xi minus x bar, so that's the average or mean, squared over the number of terms. And therefore, standard deviation would just be the square root of this. Basically, it might look a bit complicated at first, but basically what we're doing is, first we find the mean, and then we're finding how far each data is from that mean. So that's why we do this subtraction. Now, obviously, we only want that distance, right? So let's say if our mean was 6, and we have a value -3 and +9. The distance, if we just do the subtraction, this would be 3, the difference. This would, however, be -9. And obviously this, we just want to see how far this is from the mean. That's why we square it, so we always get positive values. So this basically represents the distance from the mean, or how dispersed the data is. Then we sum it up from 1 to n, and we put it all over n. So standard deviation would be the square root of this. Now, most of the time, even on your IB test, you won't be required to calculate this. All you have to do is punch in the numbers on a TI-84 and let the calculator do that for you. In most questions, the standard deviation and the variance would also be given to you. Now, I do not have an online calculator like a TI-84, but if you guys do want to see how you would calculate the mean or the standard deviation using a calculator, please let me know down in the comments, and I can definitely set that up for a future video. Now, last off, I want to talk about the properties of the mean and variance. Specifically, when we alter the original data set, what happens to the mean and variance? So, one thing a question might ask is adding a value of c to each data. Now, what happens here? Well, let's think about it. If each value is added by c, that means that totally, right, the mean will have to move up because each value is increased. And specifically, the new mean, which I'll represent as x bar prime, will be the old mean x bar plus c. That makes sense. Now, what about the variance? Variance, remember, is sigma squared, and I'll write sigma squared prime. I'll write it here. Sigma squared prime, remember, when you add a value of c to the data, you're not really making them more spread out or anything. Each of them are just larger, but they're still realistically the same distance from the mean because the mean also increased along with each of the data. So the new variance is exactly the same as the old variance. Now, if we were to multiply by c to each data, the mean would, once again, if we think about it, if each value is multiplied by c, then the mean would obviously also be multiplied by c. So x bar times c. Right? Now, with the variance, well, the variance would actually also increase because, let me give you an example. If we have 1, 2, 3 as our original data, and we multiply everything by 2, we will get 2, 4, 6. And 2 and 6 are clearly further apart than the mean of 4, than 1 and 3 are from the mean of 2. So sigma squared actually, or the variance will actually be increased by a multiple of c. So, I want to just, one last thing, I want to clarify that make sure when you're doing the operations, you're doing them on the variance, right? This is very important. If the question gives you the standard deviation, make sure to square it, change it into the variance, and then do your calculations. That's it for this video. If you have any questions, please leave them down in the comments. And if you like what we do, please subscribe and check out our Instagram as well as our website. That's it for this video. Thanks for watching. Keep an eye out for the next one. Goodbye.